Welcome back to lesson U2A1. This is video number 3. Here we're going to take a look at some examples on how to find the vector equation of a line. Recall that we just learned the vector equation of a line in the form r equals r0 plus tn, and by using the coordinates we can write the same thing in the form xy equals x0, y0. So x0, y0 are the coordinates of the starting vector, plus t, which is a scalar multiplying the direction vector with coordinates a and b. And from here we derived also the parametric equations. So x equals x0 plus at, and y equals y0 plus tb. So remember that whenever we draw the line, we can do this in two different ways. So far, we have drawn the line by when we were given 2 points. And we connected the 2 points, and that will give us the unique position of the line, just by knowing the 2 points, right? So by using vectors, we draw a line by using 2 vectors instead. The vectors are what we call vectors r0, or the starting vector, and some other vector r. And by connecting the heads of 2 vectors, then we'll be able to draw the line as required. So this would be a unique position of the line. Another way of drawing the line that we have seen in the past is by knowing a point and the direction of it. So the point and the stop. So similar to this, by using vector equations, we use a starting point. Instead of the starting point, we use a vector or a starting vector r0, and instead of the slope for direction, we use the direction vector. So in this way, we will know that the line must pass through the head of vector r0 and follow the direction of vector m. So this can uniquely again identify the location of the line. So at the head of r0 following the direction of m. Now let's take a look at example number 2. Now here we have a line that passes through point 4, 3, and it has the direction vector -7, 1, and we want to draw the line first. So in order to draw the line, we're going to start with the point 4, 3. So 4, 3 is 1, 2, 3, 4, and then y equals 3. So it's right here. This will help us draw the direction vector. And from here, we are going to apply the starting vector, And from here, I'm going to apply the direction vector, which is -7, 1. So let's draw the direction vector. So that's -7 and 1. So the direction vector will go this way around. M. So we are going to say that in order to draw the line, we have to start from the head of vector P, right here, and here draw a line that is parallel to vector M, so something like this. Let me try to do this with more accuracy. So we're going to stop somewhere in here. Let me draw the line straight. So recall that we can extend the line in both directions, obviously. And this would be our line L. I'm going to call it the line L. Now remember that the starting point in here, or this point on the line, served us as a point that represents the head of the starting vector. So we use this for r0. So r0 will be 4 and 3. And the direction vector is given -7 and 1. So the vector equation will be r equals r0 plus t vector m. So that would be xy equals r0 in our case is 4 and 3. And then plus t and -7, 1. This would be the vector equation in our case. Now, what does this vector equation represent? Where is this vector, because practically this is some vector r. So where about on this grid is this vector? Remember that this vector can be anywhere on the grid starting from 0, 0 and ending on the line. So it can have the head anywhere on the line. For example, this can be vector r. This can also be vector r. This can also be vector r, right? And just by knowing these two vectors r and r0, we will know exactly where to draw the line, okay? And that's why we say that this equation sufficiently and uniquely describes the line, okay? So if the vector, for example, that we considered will finish right here, so 4, 5, 6, 7, so for example right here, then we would say this vector r would be equal to r0 plus exactly vector m. So I've added just one m in here. So this particular vector r here will be equal to r0 plus 1 vector m. If I took this vector a little bit further, the vector r further, because I choose a different point on the same line, then this vector would be equal to r0 and then plus this vector here, which will be probably 1.2 vector m, right? So it doesn't matter how far we extend or how far we go on the line, as long as we pick a point on the line. So moving on to the next part of the question, we have to find the parametric equations. So x equals 4 minus 70 and y equals 3 plus 1t. So, and that is simply by identifying or getting the coordinates according to the equations given. And sorry, the bell went off, and I am going to continue the next tutorial in a bit. Thank you for watching. Sorry for the bell.